Okay, we'll take a look at our next page. This one has a lot of trigs, so I think we're just going to do one page this time. Of course, the first problem in saying that it has a lot of trig is not, but we'll get to it. So we have a rectangle here, and one thing it says is that this is a rectangle that has two diagonals. One of them is AC, and the other one is DB. So it doesn't really matter what order you put those in, other than A and C have to be opposite, as do D and B. But the thing to remember is that A, C, and DB, if those are diagonals, the two diagonals of any rectangle have to be the same as each other. They have to be congruent. So one of the principles they use in construction all the time to make sure that a building is in fact square is you actually build it and then measure your diagonals and make sure that you have them matching. So if we added 17 to both sides, we're going to get 42. And so again, a quick division, x equals 14, not too bad. Okay, now when we get into problems 19 through 26, this is where I feel like I should go kind of slow. So remember, this is a little SOHCAHTOA story, right? So remember, the definitions of trig is that the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is the opposite over the adjacent. So that being stated, when you look at this problem right here, if you're referencing the angle right here, then these two values are far away, and this is a hypotenuse. So in both of these cases, we're taking the sine of the given angle. So we had them side by side, and this is designed to highlight something very specific. That when you do the sine, that is the opposite, the far away one over the hypotenuse. That is the far away one over the hypotenuse. Now, what we're trying to do is highlight the fact that sometimes when you set that up, the variable's in the numerator, sometimes it's in the denominator. So if you were to cross multiply this problem, that actually helps because we really do not like the fraction, that variable to be in the denominator. So really, since x is being multiplied by the sine of 57, I need to divide both sides. So if I took the 17 and divided it by that sign, I would end up with 20.3 would be x. However, over here, you'll notice that the x is in the numerator. So all I really need to do is multiply both sides by 25. Those would cancel. And so all I need to do is take 25 times the sine of 43. And I would get x is 17.0 if we were rounding the nearest tenth. Okay, now the next phase is we're jumping into tangents because what you'll notice is neither of these have any hypotenuse shown. So we've got the tangent of 31 is opposite. Oops, I wrote a 30. 29 over x. And over here, the tangent of 68 would be opposite over adjacent again. The far away one over the close one, but not the hypotenuse. So very much in the same style of what we did, if you cross multiply to get that variable out of the denominator, all we need to do is, since x is being multiplied by that tangent, is I need to divide both sides by the tangent. And I got x is 48.3. Whereas over here, just like the other one, I need to multiply both sides by 35 to get rid of that denominator. And 35 tangents of 68, we're looking at 86.6. Cool. All right. Two more of these to go. We, of course, have a cosine. We have a sine, we have a tangent. So, of course, the cosine's coming. The cosines of the angle is the adjacent over the hypotenuse or the adjacent over the hypotenuse. And we're being very consistent. Now, let's keep in mind on the test, you'll have to keep your wits about you to decide which, what is exactly happening in the problem that we have. But of course, we're going to cross multiply to get that variable out of the denominator. And then, of course, we're just practicing that skill that when that happens, that's going to take you, and I'm going to have to divide to get rid of that multiplication. So 63 divided by the cosine of 19, and we're good to go, 66.6. But over here, the x is in the numerator, so I just need to cross multiply in order to multiply both sides by 127. Cosine 15. X would be 122.7. Now, one thing that I haven't stressed as we went through all of this, one of the fundamental theorem things says that of geometry says that when you look at triangles, the relative sizes of the angles in their opposite sides have to match. So if you look at 57 is opposite 17, the 90 is quite a lot larger, and so is 20. Those things happen throughout all these problems. So although you did not need to do that for these problems, you notice this guy would be 22 because we need 180. So you'll notice that 22 is opposite 35. Well, 68 is a much larger angle and therefore opposite a much larger side. You can see little remnants of these things right here. 59 is quite a lot larger than 31, therefore x should be quite a lot larger than 29. Now, that doesn't actually necessarily give you the perfect answer, but keep in mind on a standardized test, sometimes that'll help you narrow down your responses because you'll say, oh, wait a minute, that angle has to be smaller, therefore the side has to be smaller. And then our last two for this one is this is an adjacent and a hypotenuse, so that would be a cosine, but it's set up a little bit different because I don't have the angle, I want the angle. So what I need to do is I need to use the inverse cosine, and I'm asking the calculator to go backwards and find out the angle that would go with that. And so I got a 63.4 degree angle. Now this yeah, I guess that'll work. And then over here, this is opposite over hypotenuse, so that would be a sine of theta, would be 11 over 24. And so again, I would take the inverse sine, which again, some people will actually call that an arc sine. That's an equivalent terminology. That would be 27.3 degrees. All right. So I think that was page 5, if I'm doing my count right. And hopefully that was helpful, and I'll see you guys back in class. Bye-bye.